We've all heard of the famous Fibonacci sequence, starting with 0 and 1, with the next term being the sum of the previous two terms. The first couple terms are 0, 1, 1, 2, 3, 5, 8, and so on. The Fibonacci sequence is found abundantly in the world of biology, number theory, and applied mathematics, and today we're going to use linear algebra to find any term in the Fibonacci sequence. To start, let y sub k be the kth number in the sequence. Then, by nature, we get y sub k plus 2 equals y sub k plus y sub k plus 1, with y sub 0 being 0 and y sub 1 being 1. This is what we call a recursive function because each term is defined by previous terms. In this case, any term other than the first two is defined by the previous two. Factorial is another example of a recursive function. Now, let us have vectors u sub k as y sub k and y sub k plus 1 as shown. This says that u sub, let's say 5, will return the fifth and sixth term in the sequence. But how do we find u sub k mathematically? It turns out we can use the recursive equation u sub k plus 1 equals a times u sub k, where a equals the matrix 0, 1, 1, 1. We use matrix A for a couple of reasons, but one that may call out to you is that its eigenvalues are 1 plus or minus root 5 over 2, also known as phi, or colloquially known as the golden ratio. This equation is helpful because if we substitute u sub k with a times u sub k minus 1, and repeat it all the way to u sub 0, we get u sub k plus 1 equals a to the k plus 1 times u sub 0, or we get u sub k equals a to the k times u sub 0. Do you see it now? If we substitute a and u sub 0 for their numerical values, we get that u sub k, which gives us any Fibonacci terms k and k plus 1, is determined by a raised to the kth power multiplied by the vector 0, 1. Let's test it out. The 8th and 9th Fibonacci terms are 21 and 32, and if we plug in k equals 8, we should get a vector that looks like this. And if we go over to a calculator, would you look at that? That's pretty cool. Anyways, thanks for watching this video, and I'll see you in the next one.